Well, we're live again. CNBT 1311. This is video 5. More masonry. Wow. Isn't masonry fun? It's an ancient building medium. I mean, guys, we've been building with stone and cut stone and raw stone and brick and stuff for centuries and centuries and centuries and centuries. All right, this page is this page describes the different kinds of bonds. Running bond. It's commonly used for cavity, remember a cavity wall, and veneer walls, and it's composed of overlapping stretchers. Okay, so this is a stretcher, remember, and here's the head joint, and here's the bed joint, and this allows for one of your stronger bonds, because if this head joint begins to crack, it's going to stop right there. Okay? Now, this is a common bond. It has a course of headers between every 5 or 6 courses of stretchers, also known as the American bond. Okay? Has a course of headers. And what's a header? What's a header? A header is one of these laid where you're looking at the small end, and the long end goes to the next wythe, right? Okay. This makes for a very strong bond. It's still laid as a running bond. You'll see that this joint hits a masonry unit, that joint hits a masonry unit, and you do this for 5 or 6 courses, and you tie the walls together, the two wythes together. All right. Now, if you're going to do this, then your second wythe is going to be what? It would have to be the same modular units, right? So it could lay together. All right. All right, stack bond. I'll fire you if you give me a stack bond. Stack bond has successive courses of stretchers with all the head joints are aligned. As you can see, this is a very weak layout. That head joint cracks through differential settlement or anything else. If you get differential settlement in something like this, you'll see a crack in your brick running along the mortar joints maybe, but okay, it ends up deadheading at some point. All right, this is going to go straight up through these head joints. Bad. Okay. Because units do not overlap, horizontal joint reinforcement is required. No kidding. In unreinforced walls. You do me a stack bond, I'm going to fire you. All right, a Flemish bond. Apparently the Flemish like this bond. It's alternating headers and stretchers. So they'll do a header and a stretcher and a stretcher and a header and blah, 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 blah. Okay. And sometimes he makes a point, and I've seen architects do this. They'll take a darker brick for the header and a lighter brick for the stretcher, or vice versa. Flemish cross bond. Okay. It's a modified Flemish bond in which courses are alternate headers and stretchers with, and sometimes they'll alternate the color of the brick, which is a pain for your masons because they've got to then figure out, okay, every 2 of these is one of these, and every so many of these is this one, and blah 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 blah. That adds expense to your project, and all kinds of patterns and stuff. Here's a Flemish diagonal bond. I'm sure your masons are going to love you for this. All right. So anyway, it's you know why it's called a diagonal, because the different masonry units are on a diagonal, and you can just go crazy if you want, and have all the masons in the area hate you. But some neat things can be done with this. I'm not downplaying this. I'm not saying you shouldn't do it. Okay. Let's see here. This is an important note we'll get to in a minute. We'll get to that in a minute. Garden wall bond is used for lightly loaded boundary walls as a sequence of a header and 3 stretchers in each course, with each header being centered over a header in an alternate course. Now, why can't this be a heavily loaded wall? Yeah, it could if it was a solid wall cavity that was filled with grout and reinforced. It could be. If this is a true header, then it's going to go tie the 2 withes together. English bond has an alternating course. Has an alternating courses of headers and stretchers, in which the headers are centered on stretchers, and the joints between the stretchers line up vertically in all the courses. Okay, so as you can see, in this case, each head joint is captured by a solid piece of masonry unit above it, right? So, thing to remember though is to minimize the cutting of brick and in our block. Cutting CMUs is a pain. Cutting bricks easier than CMUs. To minimize the cutting of brick and enhancing the appearance of bonding patterns, the major dimensions of masonry walls should be based on the size of the modular units used. It's just like a 4x8 foot sheet of plywood, right? That's the normal for the sheetrock or plywood or decking. Then your layout should be on that module, 4x8. So whatever masonry you're going to get, if you decide to use Billy Bob's masonry company, you get with Billy Bob and find out what his true dimensions are for the block. And if you're mating common masonry units up, like what we would consider brick on the street and a CMU, then those are going to have to be modulared out. So you want to eliminate the number of cutting. You can't totally eliminate the number of brick cuttings, okay, but you want to minimize it to the best that you can. All right, let's move on. All right, structural clay tile. Structural clay tile is hollow tile of fired clay having parallel cells or cores and used typically in constructing walls and partitions. Now, there's an LB grade and there's an LBX grade, okay? LB is load-bearing clay tile suitable for masonry walls not exposed to frost action or in exposed masonry where protected by a facing of 3 inches or more of stone, brick, terracotta, or other masonry. In other words, there's a veneer on it, okay? LBX grade, load-bearing structural clay tile suitable for masonry walls exposed to weathering or frost action. So LBX is suitable for exposing to the weather. Structural facing tile is structural clay tile having a glazed surface. All right, structural facing tile means this stuff has a glazed surface. Glazed like your bathroom tile would be glazed surface. Okay, I used a lot of this in wastewater treatment plants in the operation rooms and stuff like that. Why? Because you use a high strength grout in here with a plasticizer in it, which makes it very, very water resistant. There's a coping down here, the cove bases, and you come in here with a water hose and hose down these walls because all this is clay. Glazed. It's a glazed surface. The company that used to sell this and marketed it down in this area was called Spectre Glaze. I have no idea if they're even in business anymore. This was back around the time that we were using parchment to write our reports on. I'm just joking. We didn't. We had paper. But used miles of this stuff in water and wastewater treatment operation plants because of the maintenance. You come in and clean these walls, really, really easy. Okay, they had a structural facing tile has a grade of FTS and an FTX. Okay. Now the FTS is structural facing tile suitable for exposed exterior and interior masonry walls and partitions where moderate absorption, slight variation of face dimensions, and minor defects in surface finish and medium color range are acceptable. The FTX grade is a smooth structural facing tile suitable for exposed exterior and interior masonry walls and partition where you have a low absorption and low stain resistance are required, where a high degree of mechanical perfection and minimum variation in face dimensions and narrow color range are desired. This is what we spec'd, was the FTX grade in those operation rooms for the water and wastewater treatment plants. And some old schools around this area used to use these in their walls. I mean, little kiddies and stuff, okay? They just come in and basically pressure wash the walls and stuff like that. Okay. You've got to get with your manufacturer. These are not cheap. Okay, as you can probably already gather, it's not cheap. Okay. Nothing in conventional block masonry is cheap. Okay. All right. And they had them in all shapes. Here's sills and caps around the windows, corners and jambs. They'd have a radius corner. This would be glazed. You had your stretchers, your cove bases, so you didn't have to put coving down here on your floor. It was quite a neat product. It's expensive as all get out, but it works real well. And of course, this is a metal door jamb. We'll get to doors later, and a metal header. And they came hollow for what kind? A lintel beam, right? Packed it with grout and rebar. Pressure pump grout in there, which is more expensive than an open cell. All right, let's see here. 6 T shapes have a nominal 5 1/3 by 12 inches, and 8 W shapes are this dimension. Your mileage is going to vary. And nominal dimensions include the thickness of the mortar joints. So if you went and measured one of these, it's not going to be 8 by 16. Okay, that 8 by 16 includes your mortar joint. All right. All right. Let's see here. Typical wall sections. Here's your cavity wall again. There's nothing in it. There's just an 8-inch wall. Two of the small ones stacked together. 6-inch wall, and then a 6-inch wall would be a 2-inch width and a 4-inch width. 2 4-inch widths, and a cavity wall would be 4-inch inner width of structural facing tile with an outer width of brick. So this would be your facing tile, and this would be your outer width. But when we spec this, we just used it also as the exterior. Glass blocks. Oh, these are lovely. Some people love these things. They're expensive. If done right, they look kind of neat. A lot of people like to put these in their bathroom windows in place of a window for a bathroom. So you can have natural light coming into your bathroom, and people can't see your self in your birthday suit, because they're not like a window. They're not like glass. They're glass blocks. All right, so black glass block is a translucent, not transparent, it's translucent, hollow block of glass with clear, textured, or patterned faces. It's made by fusing two halves together in a partial vacuum inside. So if you have gas-filled windows in your house, two-pane or multi-pane, what does that do? It helps insulate. So there is some insulation value to these. When you go do a heat analysis, a heat load for sizing your HVAC system, and you've got a big one of these, you got a different heat transfer through this. just like you go through your R values for all your walls and everything else. All right. Glass blocks may be used in non-load bearing exterior and interior walls. Non-load bearing, exterior and interior. And in conventionally framed window openings. So you knock a window out and you can put these in there. My wife wanted to do that when we remodeled our bathroom, but because that window was a bay window and an extra bedroom, I just extended the bathroom wall out to the edge of that window, and we converted that bedroom into her dressing room across the hallway from the master bedroom. And she did not get a glass block wall. Even though she is she who must be obeyed, she didn't get her way on that one. All right, so they're laid in a type S or type N mortar. You can go back and look at that. What was the strongest mortar? Wasn't that a type M? Then it goes to S, then goes to N. There's nothing that says you can't use an M. Joints at least 1/4, but not more than 3/8 thick. Typically, a wall panel is mortared at the seal support and provided with expansion joints along the top and sides for allow movement and settling. Glass does expand at a different rate of expansion than other building materials. And you can get these in all manner of patterns, like we said. Here are the nominal face dimensions. Nominal. Your mileage may vary depending on the manufacturer, and the thickness may vary. So the best thing to do is what? You get with the manufacturer of the glass units, glass blocks you want to use before you start doing your final design, and do what? You follow their recommendations, right? Just like you would for trusses or anything else. And we're not going to beat this up. This talks about standards for loading and spans and such. Minimum radiuses, yes, you can bend these. I've seen some super fancy houses where they used glass blocks as partitions in shower areas for some reason. I mean, it looked kind of cool. This wasn't your typical track home that this was in. All right. So if you want to do a curved glass block, the best thing to do is get with the manufacturer. You can use this as a rule of thumb, but don't be surprised if your mileage varies. And I know I keep saying that. I've been involved in construction over the years for too long to accept anything. Here are some details for glass blocks. Okay, these are head sections. These are jamb sections. This will be along the side of the window opening. This is a seal section. This is a vertical stiffener. If for some reason the glass block was super high. This is a horizontal shelf support. It's like a header beam that's laid on its side to give the wall, as the wall's going up, some stiffness. Your structural engineer and your glass block manufacturer should be able to help you with this. There's a C-channel jamb section on the side, and you can see there's a backer rod and sealant, and let's see, this would be an elastomeric pad to allow for expansion and contraction. Same with this expansion strip. Word of warning about expansion strips: be careful with the material you pick for these. You don't want an expansion strip that absorbs water or will degrade over time. So be very careful with the material that you use for expansion. You want something that doesn't absorb water. Because if it absorbs water, the mold's going to grow in it, right? Adobe construction, we are not going to beat this up. Adobe is sun-dried clay masonry. We don't have Adobe construction down here, just like we don't have rammed earth and we don't have hay bale houses. Yes, hippies a long time ago, they came up with that. It was a big boon in Mother Earth news that, oh, we can make hay bale houses and coat the sides of the hay with a fiberglass cement like adobe, like a stucco, like the surface bonding I talked about in the CMUs. But I don't know. I grew up baling hay. I was still baling hay up until about 6 years ago when I finally sold my hay farm. And rats and mice love hay. They like burrowing in that stuff and making their nest in there. So if you want your walls made out of hay, go ahead. Forget the Three Little Pigs story about the little pig that had his house made of straw. And when the wolf came and huffed and puffed and blew his house down, go ahead. But adobe sun-dried bricks, and in Nuevo Mexico, or Arizona, or Nevada, where they don't get a lot of rain. Now, there's some places in Arizona that do get a lot of rain up in the mountains, but down in the desert and in the Llano Escondido area of Texas, where they don't get a lot of rain, it might be a viable option, but it's not down here, so we're not going to beat this up. If you just have a hankering for designing an adobe house someday, well, I do some research, and you've got the book. So enjoy yourself. Rammed, oh, this is so cool. Yes, we'll make a dirt house. Rammed earth have a low tensile strength. Well, no kidding. And a compressive strength of about 300 psi. All right. The strength of adobe and rammed earth construction lies in the mass and homogeneous nature of the wall. What kind of earth material are you actually using? Okay. Rammed earth is also called piso de tierra. Okay. It's another traditional building material. It's essentially a stiff mixture of clay, silt, and silt. Yeah, you love that? Go back to your geotechnical stuff, the soils, right? Sand and water that's compressed and dried within forms as a wall construction. The soil mixture should contain less than 50% clay. Well, that's because it expands and contracts, right? All right. And silt, and a maximum aggregate size of 1/4 inch. Salt water should never be used in the mix. Okay. All right. This is funny. I forgot that he had this in here. Salt water. You never use salt water for mixing anything, okay? Except for gargling if you have a sore throat, maybe. All right? Or you had a tooth pulled and they told you to gargle with salt water. You don't use salt water or nasty water to mix your cement either. Man, it will ruin that calcium carbonate. Do not do it. So anyway, and they're rammed with slip forms, and they're not reinforced. They could be reinforced, but they're not. And that's enough about that. Okay. So I'm not going to tell you adobe or rammed unless you want to be tested, but I'm not. Okay. Now, if you can get by with this in the climate you're in, then fine. An adobe structure, a rammed earth structure, if the walls will stay together, maintain heat really well. But so does a concrete block house. If you do 2 wides instead of adobe, you do two wides of typical CMUs. All right, you've got a super thick wall that's got enough thermal mass that between the night and the day, because out in the desert it's hot in the day and it's cold at night, right? So adobe was used in that area. Again, it goes back to Frank Lloyd Wright's Usonian architecture. You use this stuff in the environment. So yeah, if I lived out in White Sands, New Mexico, that might be an option. Well, it won't be for me because I'm just not going to do it. I'll use concrete masonry units and let the sun heat that puppy up, and then at night, the heat will finally radiate into the house and make the house warm at night as opposed to it being cold outside. All right, so enough of that. Stone masonry. All right, stone can either be cut or can be random rubble. Random rubble means that it's just the normal size of the stone. You didn't do anything with it. You didn't broke it, you didn't break it, you didn't square it off, you didn't do anything. You just start stacking this stuff up. Uh, so, coarse rubble is a masonry wall of broken stones having approximately level bevel joints and broad at intervals to continuous. So that means your mason has to go through here um, um, and try to fit this stuff together like a puzzle. All right. So you think this is going to be more expensive than regular modular masonry units? Well, you're absolutely correct, especially if you're going to try to use this as a structural wall and not a decorative wall. All right. And of course, your mortar joints are held back from the face of the stone. And why is that? Well, because if you're going to spend all this money on an earthy looking stone structure, then you're going to want it that way. Now, squared rubble is a masonry wall built of squared stones of varying sizes and coarse at very third or fourth stone. Okay, now squared rubble means that the stones are mostly flat square like flagstones or something like that. Random ashlar is built with stones in discontinuous courses, but this isn't some random stone you pulled out of a riverbed. These stones are faced and they're cut, right? So an ash, oh my God, I can't speak. Ashlar refers to squared building stone. It's finely dressed on all faces, adjacent to those of other stones, so as to permit a very thin water joint. What you're basically doing is you're trying to take one of these boulders up here and you're squaring it off on all the sides. How many sides does this have? 1, 2, 3, 4, 5, and 6 underneath, right? On all 6 sides to attempt to make a modular deal. This is what the Egyptians did when they built the pyramid. They made ashlar building units out of stone that they cut in some quarry somewhere. I mean, unless you're one of those people that believe that aliens built it for them or something. Yeah, I had a professor in college and who just knew that the pyramids were built by aliens so the aliens would know where they were when they got to Earth. And I'm sitting in the back of the classroom. I raised my hand and I said, sir, with all due respect, if these aliens can travel through interstellar space at light speed and they can navigate and not hit asteroids out there, do you really think they need a pile of rocks on the Earth to tell them where they're at when they get here? And he got really indignant with me, and he goes, well, what do you think they're for? And I said, well, if you look on a map, then 3 pyramids look to me like survey markers, the big one, and you got them 2 offset, so every time the Nile flooded, they could run back up the Nile and do a backside on the big one and do triangulation on the others. You can reset the boundaries of Egypt. He goes, well, that's just ridiculous. That makes too much sense. I said, well, it makes a heck of a lot more sense than aliens needing it to navigate once they got here. Besides, why would they even come here anyway? There's no intelligent life on this planet. So he did not appreciate that at all. Anyway, back to this course. Sorry about that. I just couldn't help myself. Coursed ashlar is built of stones having the same height within each course, but with each course varying in height. So you can have a flat-faced, what would be what we would call a flagstone, and then you have a bigger stone up here. But this is going to be a lot more expensive than commercially made modular structures, okay? Because they kick out those concrete CMUs and them clay bricks. They kick out thousands and thousands a day in their plants. They put those bricks on rail cars and run them in those kilns and cook them. Anyway, all right, moving on. Broken range work is ashlar masonry laid in horizontal courses of varying heights. And as you can see, the heights do vary. Got a tall stone here and a flat one here, and then you've covered it in. And again, these things have to be cut to a modular dimension. So basically, you're taking this random rubble and you're making modular stones out of it. All right, here's an interesting term. Rustication is masonry having the visible faces of the dressed stones raised or otherwise contrasted with the horizontal, and usually the vertical joints, which may be rabbeted, chamfered, or beveled. Some of them are rough-faced. It's like you took a bush hammer and beat them up. And then, but these faces, where the bedding is and the head joints are dressed. They're squared. Okay. Again, this is more expensive than commercially made modular masonry units. All right, let's move on. Stone masonry. All right. Stone masonry. So we're going to get the structural frame. Finally, something on real. We'll get out all this ancient stuff. All right, stone masonry. We're still in stone masonry. All right. Let me check your current book. Okay, this is consistent. All right. If you go through Giddings again and you have time to stop and get a kolache and some coffee in old downtown, park your car where it doesn't get towed, and walk around those old brick masonry structures and look at the cornerstones that'll have the master mason's name engraved on it. If this was a sidewalk, there'd be a cornerstone on some of these buildings saying this was erected by Billy Bob, Master Mason, blah, 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 such and such a date. And that would be the corner that they started the masonry from. Okay, and then they'd build it up, whatever kind of masonry wall they had. Now, some of them old buildings had to have long rods and tiebacks to them to hold that over the years. And we'll get to these definitions in a minute. But how do you cap off traditional stone masonry? Well, this is a capstone. It's splayed copings. It's called a coping. I call it capstone, but well, this is a traditional capstone. Okay, all right, whatever. Splayed copings are also a capstone. They cap off the wall, just like that flashing that on that CMU wall. That's a cap flashing, like a cap on your head. All right. It's just real simple. We're going to have another video. I'm sorry. But that's okay. It's okay. Not like we got anything else to do, right? All right. So, setting these cap flashings are a pain. And sometimes, over the life cycle of the building, they tend to fall off on poor people down on the sidewalk. They're pinned and doweled as they're put together. And this would be, you're looking at a cross section on the edge. So think about this as a long wall running down like that. This would come down like that. That would come down like that. So this rod would have holes and you'd put a connection rod in there, and this would be set on flashing and some kind of adhesive. Okay. All right. But in the ancient days, they did not put flashing on there. They put that in a bed of mortar, and they had dowels coming down here for the old ones to pin them. So I don't know why he has flashing up here. In today's adhesive market, we got adhesives that hold airplanes together. So for doing this in modern day time, yeah, we wouldn't have to use the dowels and mortar pins. Here's two vertical dowels on a cap. And this is a step flashing through the masonry. This would have to be mortar. This is a center ridge. This is called a saddle coping. This is a splayed coping. This is a capstone form of a coping. finishing a protective course on all exterior walls. And depending on the building and the masons that built it, they would get pretty elaborate. They'd have this support coping here. Then they'd have a drip stone up here. This is called a drip stone, as you can tell, because the water would come down and drip off of this, fall down, blah, blah, blah. And then they'd have, and then sometimes these had ornate stuff cast in them or carved in them, if they were traditional stone. Got CMU backing. This is a double withe construction. We'd fill the voids with grout or slurry or cementitious material. Concrete may be waterproof to prevent staining. The CMU. This is your backup withe in here, and then you'd face the CMU. The CMU would be reinforced, and then your stone, if you use these patterns up here because you wanted to, you'd have to reinforce it back to your CMUs. And the smart thing to do would be to not have a cavity wall, but to have some kind of bonding agent filled up as you're bringing up your coursework. That'll make it all work as one unitized unit. Okay. Another point is make sure in your specs that you use non-corrosive metal ties and anchors in any masonry, whether it's residential. Any of these ties need to be non-corrosive. They need to be galvanized, zinc plated, or something. Q-on refers to an exterior angle of a masonry wall or one of the stones or bricks forming such an angle, usually differential from adjoining surfaces. Like I told you, in those traditionally old buildings, these there would be a Q-on, or what was referred to as a cornerstone. And they would have a big ceremony for setting a cornerstone. They'd get the master masons out there and lay out the building, make sure it was square, and they would set the cornerstone, or as Ching calls it, a Q-on. And like I said, they would engrave stuff on here. These are cast. I think there's a building in one of these is a faced, I think it's granite, in Giddings on one of the buildings, if I remember correctly. And it has everybody that was involved in setting, and the date that it was set, and et cetera, et cetera. And sometimes inside these would be objects from the period, believe it or not, like a little time capsule. All right, long and short work is an arrangement of rectangular Q-ons or jamstones set alternately and horizontally and vertically in the corner, depending on your architectural look. String cord, or it's flush with projecting beyond the face of a building, often molded to mark a division in the wall. String courses are also known as belt courses. You don't see a lot of this because of the cost anymore. Very few people build traditional old heavy stone and brick buildings. This is the water table projecting from your string. It was made for to divert rainwater from a building. And this is a plinth, or continuous, usually projecting course of stones forming the base or foundation of a wall. Let's go here. This section up here, plinth, okay? All right. And this is a drip stone because it's at the roof, but down here it's a water table, right? Serves the same purpose. All right, that ends that. Thank God, right? You want to go back and do Adobe and rammed earth, pretend we're hippies? I didn't think so. Okay, all right. All right, how about stacked hay bale houses? Yeah, great. I bet your fire insurance would love that. Why don't you get a quote from your insurance writer on what your house made out of? Say hay bales. That'll make them happy. All right. Let's see. This is 35, 36, 37, 38, 9. I hope that this goes to 40. So 40, 40. Oh my God. We'll see this for last. Wow, this is cool. 48, 49, and they're all right. Got here. Okay. All right. So what video is this? This is video 5. This will be video 6. If we had a face-to-face class, we'd be doing this anyway, just like this. And we'd have to have a giant pot of coffee or something in the classroom, right? Yeah. All right. We'll see you on the next video. Wow.